Okay, we'll continue with part D of problem number 5. It asks for the nearest whole number. What is the maximum number of mosquitoes for time t greater than or equal to 0, less than or equal to 31, and show the analysis that leads to your conclusion. And so I state that since r of t is continuous on the closed interval from 0 to 31, by the extreme value theorem, an absolute maximum exists, and it must occur at a critical value or an endpoint. So I make a table of r of t for certain values of t for the critical values and endpoints. My endpoints are 0 and 31. I know at 0 there are 1,000 mosquitoes. I know that at 31, time t equals 31, we've already shown that there are 964 mosquitoes. What still remains to be seen is how many mosquitoes there, whether there are any critical values in between 0 and 31. So I'm going to go back to my function, and I want to graph it and look for the 0. So I'm going to go to Window. You can see that I have the x value set up from 0 to 35 by 5. That'll cover from 0 to 31. And then my y values are set up from negative 10 to positive 10 by 1. I just want to see what's happening around the x-axis. And so I go ahead to graph that. And I'm going to get something like this. I do have two zeros. The first one, at the first one, the derivative of the rate changes from positive to negative. So that's going to be a relative max. The second one, at the second one, the rate changes from negative to positive. So that will be a relative min. So I'm just going to quickly find those values. I'm going to do second, and 0, option number 2. And I want to look from 0 to 10 for the first one. And guess it appears at 7.854. And if I want to, I can store that value. Remember, I would do that. Second, quit. If I hit X, you can see that that's still there. And I'm going to store that value in A. I have that. Now if I want to go back in to my graph and take the integral from 0 to A, I'm going to see that that value is 39.356, or rounded to 39, and I'm going to add 1,000 to that. And that gives me 1,039. So I'm going to add that result to my table. And there is one more 0. I'm still going to find the value because I want to show the analysis that leads to how I'm going to determine the absolute max. I go back to my calculator, back to the graph. This time I'm looking for another 0. I'm looking for that 0 between 15 and 30. Guess, and it finds it at 23.562, and I'll add that value to my table. However, for this one I know that's a relative min, and that cannot never be the absolute max. So I don't really need to determine what the quantity is at that time. So I just go ahead and identify that 1,039 was my absolute max, and so I write this happens at t equals 7.854, and the number of mosquitoes will be 1,039. So that completes this problem.